This meeting is being recorded.
Okay, Andriana, I did not understand your email. So
So I was asking if we can go back to the homework and study like problems from the homeworks for extra practice for the final.
yeah, that's fine.
Okay.
Okay, I'll take questions off of the final exam review at this time. Final exam is on Tuesday, remember that. Okay, I will have a virtual office hour before the exam from 5 to 6 on Tuesday. Okay, so 87 and 88. Okay, sounds good. So that's like the last two, right? Okay, maybe we'll go backwards in backwards order. Okay, okay. Oh my God, oh my God. There we go. Okay, so 87 says, suppose that labor costs for a building are approximated by C of X, Y. Find the X and Y that minimize the cost. So we have to do our D test here. Okay, to minimize the cost. Okay, so let's see. 87. Okay, so C of X, Y. Let's find our C of X. Okay, so just with respect to X, so that's going to be 20. X, the 6Y goes away. Then it's minus 200. Okay. See, minus 200. Everything else goes away, is equal to 0. Okay. So I can solve this directly for X because there's no Y's in here. So this is going to be 20X is equal to 200 divided by 20, and we get X is equal to 10. Okay, let's C of Y. C of Y is going to be 12Y minus 360 is equal to 0. So add 360 to both sides. And we get 12Y is equal to 360, divide by 12, and Y is equal to 30. Okay. So I can use my D test to see if this is a maximum or a minimum. Okay, is this going to minimize cost or maximize cost? I can find the partials of partials here. So C of XX is equal to 20. Okay, C of Y is equal to 12. Okay, and C of XY, well, that is just 0. Okay, if you go back up here to C of x, there's no y's involved, so everything's treated as a constant, so it's just 0. So our d test would be equal to 20 times 12 minus 0 squared. Well, that's just going to be a positive number. So d is greater than 0. Okay, so that means that there's a maximum or minimum. But what was cx of x? That was equal to a 20. That's positive. So if it's positive, it's concave up. Okay, that means that I'm going to have a minimum value. So when x is equal to 10 and y is equal to 30, okay. So when x is equal to 10 and y is equal to 30, this minimizes cost. Okay. Okay. Number 88 is a little bit more challenging, simply because the system of equations that we get is going to be more challenging. Okay. So what prices here? We have two kinds of electronic calculator that compete with one another. The total revenue function is RP. Okay, R of PQ, P being the first one, Q being the second one. Or P is the price of the first calculator and multiples of 10. Okay. And Q is the price of the second calculator in multiples of 10. What prices should be charged in order to maximize the total revenue? So I don't want to turn it into tens until the very end. Okay, let's get the raw number first, and then we'll turn it into tens. So if I do R of P, that's going to be 80 minus 12P minus 4Q is equal to 0. If I do R of Q, well, the first two go away, and I'm left with negative 4P plus 68 minus 4Q. Well, that's interesting. You get a minus 4Q on both of them. That's kind of cool. Okay. So if I were to multiply this one through by a negative, then I would get 80 minus 12P minus 4Q is equal to 0. And I'm going to switch this around. I'm going to do negative 68 plus 4P plus 4Q is also equal to 0. And I can add these three lines together, these two lines together. 80 minus 68. Okay, I think that's 12. Okay, and then this is negative 8. P, is that right? So plus 68. Okay. Price should be charged to maximize the total revenue. Let me just make sure I did this correct. 80, 12, and negative 4Q. That's correct. Negative 4P, 68, and negative 4Q. Yeah, looks good. Okay, so 12 minus 8P is equal to 0. Oh, okay, yeah, I get it now. Okay, so this is, I'm going to subtract 12, right? And we get negative 8P is equal to negative 12. Okay. Divide by negative 8. And P is equal to 1.5. Okay, so now I got to figure out what Q is. Okay, Q, well, so if 80 minus 12P minus 4Q is equal to 0, then 80 minus 12 times 1.5 minus 4q is equal to 0. So 12 times 1.5, what is that? 18. So 80 minus 18 minus 4q is equal to 0. Okay. 80 minus 18, I believe that's what, 62? Minus 18. 62 minus 4q is equal to 0. Subtract 62, I get negative 4q is equal to negative 62. Divide by negative 4, and q is equal to 15.5. Okay, so we get p is 1.5 and q is equal to 15.5. But again, these are in tens, so I've got to multiply both of them by 10, and I get p is equal to $15, and q is equal to $155. So the first calculator should be sold for $15, and the second one should be sold for $155 to maximize the revenue, the total revenue. Okay. Okay, others? Gabriel says if f double prime of x is equal to 0, that's a saddle point. Now, a saddle point occurs when it's when the d is less than 0. If d is equal to 0, then it's inconclusive. Okay. Divergent? No, we're not talking about convergent or divergent. So that's usually when we talk about functions and sequences and series. So it's not, we don't converge or diverge to anything in the third dimension. Okay, going backwards. Can you do 84 and 86? Sure. Okay, so find the partial derivative, find f sub x, 84. Okay, so this is going to be 3x squared. Okay, f sub x is 3x squared plus, this is going to be 8x squared times y. Okay, plus 8xy. Okay, plus, with respect to x here, this is going to be plus 7y cubed. Okay, find 86, find y of this function. Okay, so first we take the derivative with respect to y, f sub y. Yeah, move this up a little. F sub y. And that's going to be 8x cubed, because that's just going to be the constant in front of y, minus 14y, and then the 2x is nothing. So that just stays there. So now we just take fyy. Okay, and we want to take, with respect to y, well, the only y variable here is the negative 14y. So the derivative of that is negative 14. The rest of this just goes to 0. Okay, next. No, that's it. The final exam consists of 20 multiple choice questions. However, you do need to validate your answers. So you'll upload on the 21st question, you'll upload your exam. Okay, so we go to assignments here. So exam, final exam, here we go. Okay. Okay, so I look at this thing. Okay. Okay, you'll see. Ooh, don't show too much. Don't show too much. Where's my questions? Let me stop my sharing real quick. And then I'll get my questions. Okay, but it is multiple choice, but you do have to justify your answers. Okay, let's see. Oh, there we go. So yeah, see, question 21. Okay, so go back to sharing. Sharing is screen. Okay. So if you go back here, you'll see. I don't know why it jumps like that. You'll see that question 21. Okay, there's question 20. Okay, question 21 here. It says, please upload all your work for each of the previous 20 problems here as a single PDF or .doc file. Okay, so you'll upload your justifications for the multiple choice for the previous 20 questions. There's only 20 questions, so I try to do a smattering of each from each chapter. Okay, like 3 questions each from each chapter. Okay. So just keep that in mind. You will have 3 hours from 6 to 9, I believe. Go back. Oh, 10. I put it at 10. Oh my gosh. So 4 hours to complete this thing. Okay. I was a little too generous there. Well, I'll leave it. I'll leave it till 10, I guess. Okay. You should be able to, you should have plenty of time. Yes, yes. So everything in the last, in the class, chapters 1 through 6. Yes, the format is different for this test. It's just multiple choice, and then you upload your answer. There is no Pearson questions. It's just multiple choice. Okay, and then you upload your work. Does that make sense? I don't know how better to explain that. Rid of the exam there. Okay. Any other questions on the review? $82. Okay. 82. Okay, number of cows that can graze is approximated by this function. Okay. where X is the number of acres of grass and Y is the number of acres of alfalfa. If each ranch has 20 acres of alfalfa and 80, how many cows can graze? Well, we're just going to plug it in. Okay. So this one's really easy. It's just a plug and play. So it's C of 2080 is equal to 9 times 20 plus 5 times 80 minus 8. Okay. And this comes out to 812 cows. Moo cows. Move over. Something like that. Is that right? That doesn't make sense. Is there something wrong with? Oh, it's backwards. Ooh, I did it backwards. That's tricky. Okay, so it says where the number of acres of grass is X. Okay, and there's 80 acres. Okay, so this is 80, 20. There we go. 80, 20, and it comes out to 812 cows. Okay. 9 times 80 plus 100. Yeah, minus 8 is 812. That's correct. Okay, next. Okay. Okay, so it was 70, 71, 72, and 80. Okay, 70. Okay, so let's do this one. 70, 0 to b of 4e to the x dx. I can pull this 4 out in front. Okay. So the integral of e to the x is just e to the x. So this is 4 times e to the x evaluated from 0 to b. So this is 4 times e to the b minus e to the 0. But e to the b is 1. Okay, or sorry, e to the 0 is 1. And so I just get 4e to the b minus 1. And you could distribute that if you like, and you get 4e to the b minus 4. Okay, 70. Okay, so 71, manufacturer determined that its marginal cost per unit produced is given by this function. Find the total cost of producing the 301st through the 400th unit. So we want to integrate the 301st through the 400th unit. Okay. And so this is 0.0006 x squared minus 0.4x plus 84. Okay. And so this is going to be 0.0006 x cubed over 3 minus 0.4x squared over 2 plus 84x. evaluated from 301 to 400. I could simplify this at 0.0002, 0002 x cubed minus 0.2 x squared plus 84x from 301 to 400. Okay, so plugging in the 400 and then I go 0.0002 times 400 cubed minus 0.2 times 400 squared plus 84 times 400 minus 0.0002 times 301 cubed minus 0.2 times 301 plus 84 times 301, 2 times 301 squared. Okay, so plugging all that into a calculator for 71, we would come out to 1,782, 1782.02, I believe. You can check my work on that. Okay, 72. Okay, use numeric integration feature on your calculator to find the integral. Basically, you're on a computer, so you can just plug that into a computer. I would go to any integration site. You won't have one of these on. This is more for if I was teaching it in the classroom face to face. But you know, I go to Wolfram Alpha myself, and I would just say integrate t times natural log of t from what was it from? Don't remember now. T from 1 to 6 dt from 1 to 6. Oops. Where's my page? Oh, it was here. Ah, it went away. That's not good. Okay, let's try this again. Integrate t ln of t dt from 1 to 6. Enter. Okay. And they're getting about 23.5 or so. Yep, 23.5016.017. Yeah, looks good. Okay. Go back there. Okay, 80. Evaluate the improper integral or state that it is divergent. Okay, so yeah, so how's this going to work? Well, we have x to the negative 3.325 power, right? And we want to integrate that, which means that we want to go up 1 power and then divide. Okay, and then divide by that 1 power. Okay. Divide by negative 2.325, right? Okay. Okay, and then we're going to say that this goes from 1 to b, but we're going to take the limit as b goes to infinity of this thing. Right? So this is going to be equal to the limit as b goes to infinity of b to the negative 2.325 over negative 2.325 minus, now we're going to plug in 1 here, minus 1 to the negative 2.325 over negative 2.325. Okay, and so I could drop this b down below and rewrite this as the limit as b goes to infinity of 1 over negative 2.325 b to the 2.325 power. Okay, but what happens is this, as b goes to infinity, as this thing goes to infinity, what's 1 over basically infinity? Well, that's 0. Okay, 1 over negative infinity is 0. So this thing goes to 0. And the two minus signs are going to cancel here. This is going to be plus. Okay, 1 to any power is just 1 over 2.325. So the only thing that survives here is this, 1 over the 2.325. Okay. Share my screen. The whole thing. Okay, any others? Okay. Okay, determine whether the function is increasing and where it is decreasing. Okay. So we kind of have to factor this thing. Okay, to find the zeros. Let's find the zeros first. I'm going to factor x cubed out of this. This is going to give me 1 minus 3x. Okay. Okay, so that's f of x. Okay, nice, nice, nice. Okay, so I could factor that and set that equal to 0. Okay, that's going to tell me where my zeros are. Okay. May or may not help. Let's actually not find the zeros. Let's find the where the let's do the first derivative test here. So let's do f prime of x is equal to 3x squared minus 12x to the third. Okay, and now let's factor that guy. Okay, so this becomes 3x squared times x minus 4, I believe. 3x, nope, it's 1 minus 4x. And 1 minus 4x There we go. That's better. Okay, and I want to know, well, where is this equal to 0? Well, it's equal to 0 at 0, and solve this guy for 0, equal to 0, set that equal to 0, and we get 1 minus 4x equals 0. So either x equals 0 or 1 minus 4x equals 0. So toss that to the other side, we get negative 4x equals negative 1, so x equals 1/4. So we've got a critical point at 0, and we've got a critical point at 1/4. Okay. So critical point at 0 and a critical point at 1/4. Okay, so that's where it's going to change change from increasing to decreasing. These are going to be my critical points. Okay, they're where I'm going to have maybe a relative min or a relative max. Okay, or I could get that little, saddle point as well, if we really want. Doesn't have to change to have a 0. Okay, but we're going to look on each side of these. Okay, and I could say, well, negative 1 is on one side. Okay, between 0 and 1/4, let's just do a 1/8 to make things easy. And then above 1/4 is going to be 1. Okay, so we know that that it changes, increasing to decreasing in between here and here. Okay, and so if we plug in negative 1 into this function, okay, into f prime of x is equal to 3x squared times 1 minus 4x, right? Let's plug in negative 1. Well, this thing becomes positive. The 3x squared stays positive. No matter what that is, it's always going to be positive. So this is just negative 1. Well, 1 minus 4 times negative 1, that's a positive 4. 1 plus 4 is 5, so this is positive. Let me put a little positive there. Okay, so that's a positive value. Okay, at 0, it's going to be 0. Now about 1/8. 1/8 is 1 minus 1/2. 1 minus 1/2, that's still positive. Okay, that's still positive. Interesting. Okay, what about at 1? Let's plug in 1 here. Well, if we go 1 minus 4, that's negative, so this thing goes negative. Okay, so what's this thing going to look like? Well, it looks like this. It goes down. Actually, it goes up. Let's see this. It goes like this. It goes like that. Okay, it's increasing from negative infinity all the way up to 1/4, and then it's decreasing from 1/4 afterward. It doesn't change. It doesn't change the nature of the increasing or decreasing at 0, even though that is a 0. Okay, that is a inflection point. Even though that's an inflection point where it changes concavity, it doesn't change from increasing to decreasing. Okay, it's still increasing, as we saw. Okay, so for 35, we would say it's increasing from negative infinity to 1/4. Okay, and it's decreasing from 1/4 to positive infinity. Nice. Okay, what about concavity on this one? Concavity, we have to find out, well, we still have to test, is it concave up or concave down, but we do that with the second derivative. So here we're going to take the second derivative. Okay, we first have to get our critical values, but we want to know where the function is concave up or concave. Oh, no, we don't. We can just go directly to the second derivative. So the first derivative is 3x squared plus 6x minus 1. Okay, the second derivative is 6x plus 6. Oh, that's interesting. Okay, is equal to 0. Set that equal to 0 and solve for x, and you'll get x equals negative 1. So there's only one point, inflection point. Okay, so now all I have to do is find out, well, at negative 1, okay, negative 1, we know that the concavity is 0. But what about negative 2? And what about 0? Okay, so if I plug in negative 2 in here, I get a negative result. So that's a negative concavity. That's concave down. Okay, and if I plug in a 0, I get a positive result. And so that's concave up. So this is concave down. Okay, concave down. That's an inflection point, and then it goes concave up, right? So draw it like this. Okay, so concave down from negative infinity to negative 1, and then concave up from negative 1 to infinity. So concave down, we'll say, is from negative infinity to negative 1, and concave up is negative 1 to infinity. Okay, other questions? Others? Okay, the question was asked, do you have to log in to class next Tuesday? You do not. I will not be taking attendance. Your attendance will be your exam, your completed exam. So unless you run into issues, you do not need to log in to class on Tuesday. However, your exam will only be open in that 4-hour window from 6 to 10 p.m. Okay. Does that make sense? Do I teach any higher math? It depends. I do teach Calc 2 during the summer. I teach Calc 1, Calc 2, Calc 3 sometimes during the summer. So, and then, yeah, and then what else do I teach? Sometimes I teach stats in the fall, or I mean in the spring. But I'm teaching this class again next spring. So, yeah, but summer I do teach the higher math, mostly. But I opted, they asked me what I wanted next semester. I told them the same class because this COVID thing is just a nightmare. So it's like the worst time right now too. Oh, okay. Well, I'm always in the Math Success Center. Okay, half my life is in that Success Center. So if you ever need help on any future math classes, I am there, always there Tuesday and Thursday. Okay. Yeah, sounds good. Okay, 58. Okay, model for advertising response is given by blank. Okay, where NA is the number of sold units, find N prime of 3 and interpret. Okay, so let's find N prime of A first. N prime of A is equal to 0 plus 300 times the derivative of natural log of A. Well, what's the derivative of natural log of A? It's 1 over A. So this is going to just be equal to 300 over A. Okay. So A is the number of units. Sorry, NA is the number of units sold, and A is the amount spent on advertising. In thousands of dollars. Okay. Okay, so N prime of 3, okay, is equal to 300 over 3, which is 100. Okay. Okay, and so this is the rate. This is a rate of change, okay, of N, which is number of units, per A, which is the amount spent on advertising. So this is 100 units per per thousands of dollars. Okay, it's 100 units per $1,000. Okay, so that's how much I'm spending if the number of units I've sold is only 3. Okay, that's okay. So that's the rate at which I'm spending my money. Okay, if I only sell 3, then it's basically 100 units per $1,000. Okay, which is probably not too good. Okay. So yeah. Okay, next. 77, okay. Okay, find producer surplus at the equilibrium point. Okay, so let me, I'm sure you all have this, but let me give it to you again if you don't. Where's my chat? There it is. Chat. Okay, so I think this is it. I uploaded it and then you're like, that's not right. This should be it. Okay, so here's the formula sheet, right? Yes. Is that? Yeah, same thing. Okay, it says 150, but it's 116. Okay, so we have consumer surplus and producer surplus here. Okay, so this is math, it should say 116 formulas for final exam. Here's all the formulas that we've covered. Okay, so far. Okay, and key formulas that we've covered so far in the class. Okay. I would highly recommend you read through all of these and make sure you're familiar with all of these. The D-test is here. Okay, production function, accumulated present value of perpetuity. Okay, and so we have, okay, equilibrium is when D of X is equal to S of X, and we want the producer surplus here, QP minus 0 to Q of S of X, D of X for supply function S of X and Q units at price P, Q units at price P. So let me stop sharing for a second. Okay, so this I just gave you. Okay, so this, and again, if you were to open it up and look at producer surplus, it's this guy right here. Okay, makes sense? Okay, so QP minus 0 to Q of S of X dx. Okay. So 77, right? Yeah. Okay, so QP minus integral 0 to Q, I think it was, of S of X dx, right? Okay. Find the producer surplus at the equilibrium point. Okay. So we want X to go from 0 to 4. Okay, and they looks like the equilibrium point is X equals 2. Okay. So that's fine. Okay, find the consumer surplus at the equilibrium point. Boom. Okay. Find the producer surplus at the equilibrium point. S of X. Okay, so okay. So if we plug in, if we evaluate X equals 2, but what's the price? That's what I want to know. See here for a second. So when X is $2, is X the price? That's what I need to know. Nope. X is not the price. Let me think about this for a second. Okay, so we're at X, right? From 0 to X. And then this is my rectangle. Okay, QP. Okay, so I need to know what's the value of S of X. Okay, when the price is equal to, yeah, X is P. Okay, so when the price is equal to 2, what's my supply? Okay, what's my supply curve looking like? Well, if I plug in 2 here, I get 0. Okay, so that's interesting. Okay, so we get 0 times 2 minus 0 to 4 of the square root of X minus 2 dx. Okay, let me rewrite that over here. 0 times 2 minus 0 to 4 of the square root of X minus 2 dx. Okay. Okay, so this is going to be X minus 2 to the 1/2 power. Okay. All over. Well, I'm going to raise this. Well, I could do a U sub on this. U is equal to X minus 2. Du is equal to dx. So I'm just going to treat this. Again, this is going to go from, this is 0 times 2, which is just 0. So this thing is 0, so I can drop it. So this is negative, okay. The integral from 0 to 4, I'll just put integral for right now. Integral 0 to 4 of radical u du, okay. So if I were to integrate this guy, radical u du, or u to the 1/2, this would become u to the 3/2 over u to the 3/2 over 3/2, which is going to be 2/3 u to the 3/2. Okay, but what was u? U was 2/3 times x minus 2 to the 3/2. Okay, evaluated from 0 to 4. Okay, so I can plug a 4 in here, and I get plug a 4 in there, and I get 2. Okay. Okay, 2 to the 3/2, 2/3, minus, okay, minus what? Minus plug in 0. That's negative 2 to the 3/2. Oh, which is problematic. Because this is imaginary. It's imaginary, which is a problem. And this is supposed to create a producer surplus. The problem with this is that there will be no surplus, because if you're starting at 0, you're saying 0 minus some sort of area under the curve. Okay, then there is no area under the curve. You're at 0. So for all intents and purposes, that would be 0. But I just want to run the numbers real quick to see what we would get here. It's not going to let me do it. I just want to go to u first. Okay. So let's integrate the integral of x minus 2. Yeah, because it's outside the domain. That's the problem. It's a domain issue. We don't even have to go there. We can go to Desmos. Maybe I'll get rid of this one. I don't see much value in having this problem. But if I want to, okay, let's look at y equals square root where's the square root function? There it is. The square root of x minus 2. 2, right? So we're saying, look, oops, not x sub 2. What the heck? 2, okay. So the function doesn't really even exist until 2. And there really is no area between 0 and 4. As x goes from 0 to 4, there is nothing. There's nothing here. There's no area. And then at 2, okay, at the equilibrium point, we're at 0. So x goes from 0 to, yeah, so I would venture to say that, you know, if we're integrating this thing from 0 to 4, we could only integrate from 4 to 2. Or from 2 to 4. But then you're still taking 0 and subtracting off some sort of area. So I'm just going to call it 0 at this point because of the way. Maybe I'll take that problem off. You can just get rid of it if you want. I'm just going to say that it's 0 because this is undefined. And 0 minus something undefined is just 0. And it's just 0. Okay. So you don't have to worry about that. Okay, I will give you something nicer on the exam. And I already have. Okay, any others? Okay, 59. Okay. 60, 61, 65. Okay, 59. Okay, find all relative maximum or minimum. So we want to find the y prime, where y prime is equal to 0. Okay, y prime here is equal to 1 over x minus 1. Set that equal to 0. Okay. So this is going to be toss the 1 to the other side. That means that 1 over x is equal to 1. Okay. And so I can multiply both sides by x. And I would get x to be equal to 1. Okay. So that's my critical value. Okay, so now I just need to know, okay, is that critical value, is that a max or a min? Well, let's take and find out what happens around 1. Let's look at 0 and 2. So at 0, well, that's undefined. I can't do that. Let's try 1/2. If I do 1 divided by 1/2, okay, this is where I'm looking right here. If I do 1 divided by 1/2, that's 2. 2 minus 1 is 1, and that's positive. Okay, so that's increasing. It's going uphill. Okay, the slope is increasing. If I do 2, I get a negative number, so that's downhill. So this would make it a maximum. So there's a max at, looks like -1. Natural log of 1 is 0. So max at y equals natural log of 1 minus 1. Natural log of 1 is 0 minus 1, so y equals -1. So, so at 1, -1, this is a maximum. Okay, let's see if that works. Let's go back to Desmos and see if that makes sense. Does that make sense? That if I have y equals what was it? natural log of x minus x. I think it was minus x, right? Minus x. Okay. And so, well, what happens? Well, we have a maximum at 1, -1. Okay, it was increasing up until we got to 1, and then it goes decreasing. So it is a maximum. Nice. Works. Stop. Okay, number 60. A CD store determines the following demand function for a particular CD, where Q is the number of CDs sold per day. Okay, CD is X in dollars. Finding elasticity at a price of $8 per CD, and state whether the demand is elastic or inelastic. Okay, so we need to use our elasticity of demand function. Okay, which is negative. I believe d of x over d prime of x. Okay, something like that, right? X, I forgot the x, and it was the other way around. X, negative x d prime of x over d of x. There we go. Okay. Okay, so we need to find out, well, what's d prime of x? D prime of x, okay. What's d of x? D of x is equal to radical 200 minus x squared. Okay, so I'm going to change this to 200 minus x squared to the 1/2. D prime of x is going to be 1/2 times 200 minus x squared to the negative 1/2 power times the derivative of the inside. This is chain rule times negative 2x. Okay, so the 2 and the 1/2 will cancel. This leaves me with negative, okay, negative x on the top over 200 minus x squared on the bottom, and it's to the 1/2, which is a square root. Okay, so that's d prime of x. This is my d prime of x. Okay. So if I plug this in to e of x, okay, I would get, I could do this in stages. If I plug in, I don't have to do it algebraically because I really just want e of 8, right? So if I do e of 8, that's negative 8 times d prime of x, that's negative 8 over the square root of 200 minus x squared. Okay, 200 minus 8 times 8, which is 64. Okay, all over dx, which is the square root of 200 minus 8 squared again, or 64. Okay, so this is going to be, well, this is just going to be 8, negative 8 times negative 8, which is 64, over the square root of whatever 200 minus 64 is. 200 minus 64 is 136 over 136 square root, and it's divided by another 136 square root, so that's just 136 square root. If I square that, that just becomes 64 over 136. And so what number was this again? It was 60. Okay. So what is 64 over 136? Is 0.47. This is 0.47 about, approximately 0.47. Okay, which is less than 1. So 0.47 is less than 1. So we say that's inelastic. Okay, it means that if you were to increase the price, you would increase your revenue. Okay, it's inelastic. It means your revenue has not peaked yet. Okay, what was the next one? Next one was 61. Okay, beverage company works out a demand function. Okay. The demand function, okay, at what price, where Q is equal to the quantity of soda sold when the price per can is X in cents is X. Okay, what price is the revenue and maximum? Okay, so revenue is equal to the amount times the price, right? So that's the revenue, is the amount times the price. Okay, so what's the price? Well, the price they're saying is X. So that's X. Okay. What's the amount? Well, that's what's demanded here. That's the D of X. That's the amount that's demanded. Okay. So R is equal to X times D of X. Okay, so X times D of X. What is D of X? D of X is 3,500 minus 29X. Okay, so I distribute that. So R is equal to 3,500X minus 29X squared. So now what do I want to do? Well, it says find out at what price is the revenue on maximum. So in order to find my maximum here, okay, my maximum value, okay, I have to take the derivative and set it equal to 0. Okay, and that'll be my maximum. Okay, so the derivative, R prime of X, is going to be 3,500 minus, what is this, 58? Double 29 is 58. X is equal to 0. Set that equal to 0 and then subtract 3,500. We get negative 58x is equal to negative 3,500. Divide by negative 58. And we'll say that x is equal to 3,500 divided by 58, which is about 60 cents, I would say. 60 cents, yeah. So it's approximately 60 cents. Okay, so that's going to maximize my revenue. Okay, and then 62 says evaluate this one. So we're going to evaluate. I'm going to pull the 9 out, and then we do x to the 7th dx. Okay, raise the x to the 7th to the 8th, x to the 8th over 8. Okay, times 9, and so I just get 9/8 x to the 8th. Okay, plus c. Always plus c. Always plus c. Oh, it was 65. Oh, okay, sorry about that. Okay, so you got a bonus one there. Okay, so 65, okay, is 8 times the integral e to the 4x dx. So we're going to do a u sub on this one. U is equal to 4x. Sorry, my u's and my 4's look too similar. Okay, du is equal to 4 dx divided by 4. So du over 4 is equal to dx. Okay, so this is going to be 8. Integrate e to the u du over 4. Okay, so I could cancel the 8 and the 4, and I'd be left with 2. Okay, so 2 integrate e to the u is just e to the u. So this is, let's move over here. This is 2 eu, okay, plus c, which is just 2 e to the 4x plus c. Right? Mm-hmm. Yeah. Okay, number 30. Okay, a firm estimates that it will sell n units of product after spending x dollars on advertising, where n of x is equal to negative x squared plus 150x plus 11. Find the relative extrema of the function. Okay, so relative extrema from 0 to 150. Now keep in mind that this has, okay, this has endpoints involved. So we want to know what's the relative. So the endpoints could be, can they be relative or can they only be absolute? I think they can only be absolute, but we'll test them anyway. Okay, so we want to know, does this thing have any critical values? Okay, so n of x is equal to negative x. Yeah, it can't be relative. Yeah, so relative is only going to come from, yeah. So negative x squared plus 150x plus 11. Okay, so take the derivative of this. Find our critical values. Negative 2x plus 150. Set that equal to 0. Toss the 150 to the other side. Okay, so negative 2x equals negative 150. So divide by negative 2. And x is equal to 75. So that's my critical value. Okay, and so I need to just know, is this a maximum or a minimum or what? What the heck's going on here? Okay, so this is a parabola. Okay, but we don't have to. We could do a number line and we could do 75 and then find out, well, what's happening on either side of it, right? So what's happening at 70 or 80, right? Okay, or even, we can make it even easier. We could say, well, what's happening at, I don't know, it only has one critical value, so maybe 0. If I plug in 0, I get positive. Okay, so it's going uphill. And then I have my critical value. Let's see what happens over here. Let's try 80 here. If I plug in 80 into my original, or into my, sorry, yeah, it's plus 150 into my derivative. Okay, so it's into my derivative here that I plug it in. So if I plug in 0, I get 150, okay, which is positive. And if I plug in 80, I get negative 160, which is, add that to 150, that's negative 10, and I get negative, and so it goes down. So it is a maximum. So this is going to be a maximum. This is going to maximize. Okay. Okay, this is going to be the maximum. We'll sell n units. So this is the maximum number of units. So max number of units is, okay, n of 75. Okay, n of 75. If I were to plug in n of 75, that should give me my maximum value for this. So that's going to be negative 75 squared plus 150 times 75 plus 11. Now, if I go to a calculator, don't make the mistake of thinking that this is negative 75 times negative 75. It's not. It's the negative of 75 squared. Okay. Let's see if I can grab this thing. Grab. There we go. Grab you, sir. Let's bring this up. Let's grab the calculator. Okay. Maybe I'll over here. Okay, so this is going to be, sorry, 8. What was I plugging in? Yeah, 75. That's right. So this is negative 75. The negative. Okay, it's 75 squared, and then we have to make that negative. So I'm going to negate that. Okay, so that's negative 5625 plus 150. 150 times 75 is 11,250. Okay, 11,250 on that one. Go away, Dismos. I don't need you anymore. Okay. Okay, and then plus 11. Okay, and so plugging all that in, we get 5636, I believe. So yeah, it's 5625 is half, and then 5625 plus 11 is 5636. Yeah, 5636. Okay, so max number of units is when we're spending $75 on advertising and we're getting 5,636 units. That's my maximum. Okay. Find the relative extrema. Okay, so it would be at 75,5636. That's the extrema. Okay, and it's a max. Okay. Okay, any others you'd like to see? 18. Okay. Okay, if the price in dollars of a product is given by P of X equals 1024 plus 1200, where X represents the demand for the product, find the rate of change of price when the demand is 8 units. Okay, so we want the rate of change, so we're just going to take the derivative here. Okay, so P prime of X is equal to, this is going to be like 1024 X to the negative first plus 1200. I'll just write the original like this. And then this is going to be P prime of X is equal to, okay, 1024. This is, bring this negative 1 down and then subtract 1. I would get negative 1024 X to the negative 2 plus 0. Right, so this is really negative 1024 over X squared, okay, is P prime of X. And we want to know, we'll find the rate of change of price, right, P of X, when 8 units of X are demanded. Okay, so P prime of 8 is equal to negative 1024 over 8 squared. So P prime of 8 is equal to negative 1024 over 64. Okay, and so does that reduce? 4, 64, yeah, that's 16. Negative 16. Dollars per unit. Dollars per, oops, per unit. Okay. Okay, how are we doing? Any more you'd like to see? Okay, 37 and 38. Okay, yeah. What is the max annual profit? Okay, so profit is R of X minus C of X, right? So P of X is equal to R of X minus C of X. Okay. So we're going to take 480x minus 0.02x squared and subtract off 160x plus 100,000. Okay, so let's go out here. So P of X is equal to 480x minus 0.02x squared minus 160x minus 100,000. Okay, is that right? Yep, minus 160x minus 100,000. Yep. 480, 0.02x squared. Okay, good. Okay, so let's combine the like terms here. 480 minus 160 is 320, I believe. So this is negative, let's do 320 x minus 0.02x squared minus 100,000. Now I want to see, is there a critical value? Again, this is just P of X. So now P prime of X, is there a critical value here? So this is 320 minus 0.04x and set that equal to 0. Subtract 320. Negative 0.04x is equal to negative 320. Divide by negative 0.04. Okay, 320 divided by 0.04 is 8,000. So x equals 8,000 is a critical value. Okay, what is the maximum annual profit? Okay, so the max profit, here's my profit function. Okay, I get a critical value at 8,000. Okay, I could see if it is a critical value, okay, by taking my second derivative of x and saying, is this a maximum or a minimum? Well, what is my second derivative? Well, what was my first derivative? My first derivative was right here. So if I take the derivative of the derivative, okay, second derivative here with respect to x, then that's just negative 0.04. Okay, and since the second derivative is negative, that means that it's concave down. Always, it's always concave down. Which makes sense because my original function was a parabola. Okay, it's always concave down, which means that this guy had to have been a maximum. Okay, this guy will produce a maximum. That's not the maximum value. It's the x value that's going to produce a maximum profit. Well, what is that max profit? Well, I don't know. What's P of 8,000? P of 8,000 is going to be 320 times 8,000 minus 0.02 times 8,000 squared minus 100,000. Okay, so 320 times 8,000 is 560,000 minus 8,000 times 8,000 times 0.02. Is that right? Yeah, 0.02. Oops. Is 1,280,000 minus 100,000. Okay, so I think this gets cut right in half. So this is 128,000. So
When are you off?
about 20 minutes, 15 minutes actually. Okay, 1,280,000 minus 100,000. That's just 1 million. Oh, great, thank you. 1,180,000 dollars is my maximum profit. Okay, number 38. Sorry if you didn't get a chance to finish copying that down. Okay, I'm recording, so you can always go back to the recording as well. 100,000. Okay, 1,180,000. Okay. Okay, 38. Because of material shortages, it is increasingly expensive to produce 60-liter diesel engines or 6.0 liter diesel engines. Okay. In fact, the profit in millions of dollars from producing X thousand engines is approximately blank to blank. Find the inflection point of this function to determine the point of diminishing returns. Okay, so the profit. Okay, I want to know where is it going to go from being profitable to not being profitable, I guess. Okay, so find the inflection point of this function. Okay, when does it go from concave up to concave down? Okay, so we need to take the second derivative of this thing. Well, let's look at the first derivative. The first derivative is negative 3x squared plus 18 times 2, that's 36x plus 16. Okay, so that's the first derivative. So now let's look at the second derivative. Okay, so the second derivative, this is negative 6x plus 36. Okay, and set that equal to 0, and you get x equals 6. Okay, so find the inflection point. Okay, so x equals 6. So I would plug that back into the original function, and I would get p of 6. Okay, is 498. If I plug that back into the original function here, I get 498. Okay, and so it says, this is profit in millions, right? So what's the inflection point here? The inflection point is at 498. Profit in millions from producing X 100,000 engines. Okay, so this is 498, which really kind of means 600,000 engines would produce a maximum profit of, will produce a profit of 498 100,000, 498 million, right? It's in millions, I think. Millions, yeah, 498 million dollars. 600,000 engines produced $498 million. Okay, so this is where your returns would start to diminish. So this thing goes like this, something goes like this, I think. And so it's saying that your point of inflection, okay, is right there. Okay, so yeah. But you don't need to know what the graph is to solve the problem. And if you wanted to graph it, you can on Desmos anyway. Okay. Okay, 46. Okay, supply function for a certain product is given by this, where S of P is the number of items produced when the price is P dollars. Use S of P to estimate how many more units the producer will supply when the price changes from 13 to 13.20 per unit. Okay, so we're having a change of price. Okay, so basically this is a delta X problem where the change in X goes from 13 to 13.20, which is the change in X is 20. Okay, and we're going to estimate this using our marginals. Okay, so we want to estimate the change in, estimate how many more units a producer will supply. So how many more units will the producer supply when the price changes from 13 to 13.20? So we know that delta y over delta x is approximately dy over dx. Okay, so let's take the derivative of this. Okay, so dy over dx, s prime of p is equal to 0.05 times 3x squared plus 4 times 2p plus 6. Okay, so this is going to be 0.15x squared plus 8p plus 6. Okay, that's, you know, in a sense, that's my dx dy, dx. Okay. Okay, think of this as just s prime of p as y prime. Okay. Okay, and so they're saying we want to estimate this. Oh, this is a p, sorry. These are p's. Well, whatever, I'll just change them all to x's. Just to be consistent. Okay. And so it's saying that, okay, so the x is our starting point. So x equals 13. So I can plug in 13 here in for this and multiply by my delta x, which is 20 cents. Okay, and I can get approximately what's called my differential, which is, say this is dx, right? So this is going to be 15 times 13. Okay. 15 times 13 squared plus 8 times 13 plus 6 times 0.02. Okay, so let's plug that into a calculator. 13 times 13 times 0.15 times 0.15, okay, plus 8 times 13 plus 6. is 135.35. Times that all by 0.02. And I get about 2.707. So dy is equal to 2.707. Okay. And so what does this mean? Estimate how many more units will they supply? About 2.7 units more. Okay. Approximately 2.7 units more. If I move from 13 to 1320. Okay. Oh, shoot. It should be, I made one tiny error. This is 0.20, not 0.02. Okay. So, yeah, that was where my error was. This is 27.07, which is about 27 units. So I just put in, instead of putting in 20 cents, I put in 2 cents. So that was my error for that one. Okay, and then 51, I think this will be our last problem. Okay, for the evening. 51, given the revenue and cost, or X is daily production, find the rate of change of the revenue with respect to time when X equals 15 units and dx dt is equal to 4 units per day. Okay, so this is like a kind of like a chain rule in a way. Okay, because it's with respect to time, right? It's with respect to time. Okay, so what is the daily production where X is, find the rate of change with respect to time, not with respect to X, but with respect to time. Okay, so you have to think of this as R of X of T is equal to 30 times X of T minus, okay, the change of revenue here. So all we care about is the change of revenue. So given these revenue and cost functions, we're just going to deal with the first function. This is 30 times X of T minus 0.3 times X of T squared. Okay, so we got to think of this as like the chain rule here. So this is the derivative of this is just going to be 30, okay? But then the derivative of x of t is x prime of t, or what we would call dx dt. I won't skip steps. Let's do x prime of t. Okay, minus, and then what about this one? This is chain rule as well. Minus 0.6 times x prime of t, oh, sorry, 0.6 times x of t times x prime of t, okay? Okay, where they're saying that x prime of t is dx dt. And this is dx dt. And they're saying, look, when x is 15, okay, so when x is 15, okay, and dx dt is 4, okay, can we solve this? Sure, we can, okay, for r prime of t basically, right? R prime of t. So this is going to be 30 times 4 minus 0.6 times 15 times 4. Okay. Okay, so let's see what we get here. 30 times 4, that's 120, minus 0.6 times 4 times 15 is 36. So 120 minus 36 is 84. So $84, that's the revenue, right? $84 per day. Okay. Yes, there are 20 questions. The 21st question is to show your work for the previous 20 questions. Okay, so as you go through it, you know, you're gonna show your work on a piece of paper, show your work, and then you're gonna upload that. I'll upload all your work at the end of the test. But the test is multiple guess. Okay. But I want to see your work, otherwise I can't give you any partial credit. That makes sense? Any other questions? Okay, once again, I do have office hours starting at 5 on Tuesday. So if you have any last minute questions, yes, you'll log into Canvas and it just shows up. Remember, just like you did Proctorio before, right? Well, this time it's just the whole test is in Canvas. Okay, it's just a multiple choice test. You're just going to go A, B, C, D, right? But then you're going to have all your work, and then you're going to upload your work at the very end. Okay, you have 4 hours to complete that. Don't go over time, otherwise it will not answer it. No, you do not have to log into Pearson this time. It's all on Canvas. No Pearson. Oh, sure. I mean, COVID is awful. So would have much preferred. If you do have any suggestions on what you think might make the class better, I am teaching the same class, so feel free to shoot me an email and let me know, you know, if there's anything that could be modified. You know, hopefully this time next year we're all healthy and face to face and have been vaccinated from this awful virus. I don't know. So we're just using Pearson. Anyway, with that, I will bid you adieu, and I will see you guys later. Okay.
Professor, excuse me, I have a question.
Sure.
Can I ask you this by without the all the like without everyone here?
Yeah, sure. I can create a breakout room.
Okay, thank you.
And that's Maria.
Yeah, this is Maria. Yes, it's because so if we still have how many?
I can remove Mario unless Mario.
Okay, it's because I was having some extra time to do the test. Is this time everyone is going to have 4 hours, or will I get a little bit of extra? Can I begin earlier before the 6?
Everybody's getting 4 hours.
4 hours?
Everybody gets modified.
Okay, so it's for from 4 to 6 to 10?
6 to 10.
Okay.
You should be able to complete it in an hour.
Oh my God, I get so nervous. I don't know. It has been for so long since I haven't done any math, but okay. It's just probably me with my mind. I feel like, oh my God, I'm gonna be struggling, but well,
It'll be fine.
this is my last class I need. This is my last class for Cerritos. Thank you, Professor.
Okay, sounds good.
Thank you. Bye-bye.